Hello everyone, very good evening and welcome to the BYJU'S exam prep. In this session, we will discuss question from Sedran Smith, that is the standard textbook for analog and EDC. And that is the textbook, guys. This one, Sedran Smith. I think it is visible to you. Now this is the 6th edition, Theory and Application Microelectronic Circuits. Okay, and here I am going to cover one important topic, that is what BJTs, bipolar junction transistor, chapter 3. Okay, and this topic is important for all branch electronics, electrical and what instrumentation. And this session is important for GATE examination, especially for GATE 2024. Okay, now first of all, my introduction. Myself Sanjay Rathi. I am having 23 years of teaching experience and these are my ranks in engineering services exam. Okay, now guys, you have to solve some selected numericals from standard textbook. I'm going to solve some standard questions from standard textbook. Okay, some solved example, but maximum unsolved numericals from Sedran Smith. So let me know that everything is fine, or are you solving some questions? Any suggestion? Then yes, you can suggest me, or if you have any doubt, then you can ask me. And guys, remember, I will upload the PDF of this session on my Telegram channel, that is Electronics by Sanjay Rathi. Right? If you want to get the idea about exams, that is notification about the exam, okay, or what daily dose to improve concept, if you want to solve some important numericals, then you can join my Telegram channel, that is Electronics by Sanjay Rathi. Okay, then before starting the session, this is golden opportunity for you. In coming Sunday, we have National Scholarship Test for GATE exam. Take a step towards success in GATE. You can start your journey with us. Okay, but simply you have to register here. This is free of cost and window will be open for 12 hours. Means what? 9 AM to 9 PM. You can register now and get up to 90% off on our program. Second important thing, about the workshop by Rakesh Talreja sir, comprehensive 1-year plan to conquer GATE 2025, 22nd November at 7:30 PM. Okay, you can join this session then after 2 days. Okay, then first question on your screen, that is one question number 3.10 in the circuit shown in the figure. This is very basic question on NPN transistor. Everyone use your copy, pen, calculator, virtual calculator and try to solve this question. It is a 1 mark question or it may be of 2 mark question. It may be MCQ or it may be what MSQ, or there may be numerical answer type question based on this diagram. Very simple. Tell me what will be the answer here. What will be the answer here? Then in the circuit shown in the figure, the voltage at the emitter was measured and found to be minus 0.7 volt. Is it possible to get the emitter voltage minus 0.7 volt? Yes. If it is given minus 0.7 volt. If the beta is 50, then you have to find emitter current, base current, collector current and voltage at VC. Voltage at VC. So very good evening Bhanu, how are you? Now everyone watch this. This is a very simple question. Here we are giving the two supply. One is what? 10 volt. This is called VCC. Just to keep, normally we want to keep collector junction reverse bias and emitter junction forward bias. Here we are giving the negative voltage to make this emitter junction forward bias. Why? Because in NPN transistor, remember, if in NPN transistor there are two ways to make this junction forward bias. First, NPN. First way is what? Connect positive voltage to the base. Then it is forward bias. Second, negative voltage to collector, emitter. Again it is forward bias because we have to make this junction forward bias. So there are two options. First of all, make VBB, that is the base positive, or emitter negative. So here the emitter is what? Negative. Now it will provide sufficient voltage so that this junction is what? Forward bias. Okay, then we have to find the IE, IB, IC and VC. So what are the values? Very simple one. This question is what? First question on your screen. Then that is question from Sedran Smith. First of all, if this V is given as minus 0.7 volt. So what is the value of the VB? 0. So what is the value of VBE? VBE is nothing but VB minus V. 0 minus of minus 0.7 means it is 0.7 volt. Means it is in active region. It is what? Forward bias. Emitter junction is forward bias by 0.7 volt. Now you can find the value of I. This minus this upon 10. First of all, I minus 0.7 minus of minus 10 upon what? 10 kilo ohm. Then this is 9.3 divided by 10, 0.93 milliampere. Very simple, and it is a positive value. Emitter current downward. Similarly, once you have the emitter current, then you can find the base current. Why? Because emitter current is IC plus IB. And in active region, IC is equal to beta IB. So you can say I is equal to what? IC plus IB, or in active region you can write 1 plus beta times of IB. So what is the IB is equal to IE upon 1 plus beta. So it will become 0.93 upon, what is the value of the beta given in the question? Yes, 50. Then you can put here 51. You will get the value of IB. Use your calculator and give me the value. Virtual calculator, guys. 0.93 divided by 51. Then you will get 0.0182 milliampere. Okay. Then once you have the value of IB, or you can convert it into milliampere, multiply it by the 1000, 18.23 microampere. Okay, then what is the IC? IC is nothing but beta IB. Multiply it by 50, it will become 50 upon 51. 50 upon 51, beta upon 1 plus beta is nothing but alpha into 93. So this is you will get 0.911. It is slightly less than what? Emitter current, because IC is equal to alpha IE. So you can find alpha I. So alpha is nothing but beta upon 1 plus beta. Beta upon 1 plus beta. So IE, IB, IC and VC. Now this VC is not, this is the VCC minus IC into RC. So normally node voltage, if it is asked, in numerical they will ask VC is equal to VCC minus IC into RC. Then it will become 10 minus IC, we have calculated 0.911 into RC. What is the RC? 5 kilo ohm. Then you can find the value of VC here. Into 5. 5.445. Okay, this is the value of VC. Check my calculation. Now it is very easy, but you have to check whether, what about the VCE? VCE is VC minus VE. What is the value of VC? 5.445 minus of minus 0.7, because VE is given in the question, minus 0.7. So you will get around, you can add this 5.445, right, and minus plus 0.7, 6.415 volt. Now this voltage is greater than 0.2 volt. That is nothing but VCE set, and that's why BJT is not in saturation. After every numerical you have to check. That is very important thing, because if it is greater than VCE set, okay, it is in active region, because we have assuming The BJT is an active region, and that's why we have used this formula. We have used this formula. Okay, beta IB. Now, so we have verified, but if suppose we are finding that after calculation, if here it is visible that V is less than VC is set, means our assumptions is wrong and the BJT is not in active region, it is in what? Saturation region. And you have to solve the question accordingly, saturation region. Okay, this question is clear, everyone? If it is clear, then like the session, as well as if you have any doubt, then you can ask. You can ask this. Very, very simple one. That is from the Sedra & Smith. Now, next question. Next question on PNP transistor. Normally, we are confused with what PNP transistor, because 90% or more than 90% question will be on what? NPN. NPN is preferable over PNP. Why? Give me the answer. Why we are using NPN more as compared to PNP? What is the reason? Now, in the circuit shown in the figure, measurement indicates that VB to be 1 volt. What is the VB here? 1 volt. And what is given? VE to be 1.7 volt. VE 1.7 volt. What are the alpha and beta for this transistor? What is the alpha and beta for this transistor? What voltage VC do you expect at the collector? What is the voltage VC? And alpha and beta is not given. If you have the value of the alpha, you can find the beta. If you have the value of beta, you can find the alpha, because alpha is equal to beta upon 1 plus beta, or beta is equal to alpha upon 1 minus alpha. You have to find any one value and then VC. Now, VE and VB is given, means you have to find what VEB in case of PNP transistor. VEB. In NPN transistor VB, PNP transistor VEB, and that should be positive. VEB is nothing but VE minus VB. 1.7 minus 1, that is 0.7 volt. Again, it is in active region, because emitter junction is forward biased, means it is not in cutoff. Once you have idea that emitter junction is forward biased, means it is not in cutoff. It may be in active region or it may be in saturation region. So we are assuming that it is in active region. When it is in active region, watch this. In PNP transistor, always remember emitter current inside, collector current outside, base current outside. Emitter current I is equal to IB plus IC, but emitter inside, base and collector outside. Now this is open circuit, that's why the base current will flow like this. So you can find the base current 1 minus 0 upon 100, 1 by 100. And you can also find the emitter current 10 minus 1.7 upon 5 kilo ohm. So you can find emitter current 10 minus 1.7 upon 5 kilo ohm. This is the RE. Because it is connected to emitter terminal, that's why it is called RE. That is 5 kilo ohm. Means you have 8.3 divided by 5 kilo. This is the milliampere. You can find the value 8.3 divided by 5. 1.66 milliampere. This is the value of emitter current. What is the value of base current? Base current is, this is the 1 volt, this is the 0. 1 minus 0 by 100, 1 by 100. Milliampere means 0.01 milliampere. Now, how you can find the value of beta? Then you can find the value of beta for this particular diagram, because you have idea one minute, what is the problem here? Okay. I is equal to IC plus IB, right? So what is the I is equal to 1 plus beta times of IB. So what is the 1 plus beta is equal to I upon IB. So it is 1.66.01. This is the value of IB. 1.66 divided by 0.01. Now it will become 166. So beta is 165. How many students you have given the answer? 165. So Bhanu Prakash, what is the answer for this question? You are not giving answer, everyone. That is a very, very simple question. 165. That is the value, and this is the VEB. Now if you have the value of the beta, then you can find the value of the alpha, because alpha is equal to beta upon 1 plus beta. It is always less than what? Because it is, remember, if it is a numerical answer type question, you have to give the exact value here, because it is a very, very easy question. You can't give the approximated and so on. So you will get 165 upon 166. So 165, that is the beta upon 1 plus beta. And you will get around 0.9939, nearly equal to 1. Nearly equal to what? 1. Yes, correct. Then, what is asked in this question? Find the value of alpha, find the value of the beta. That is okay. Now, what is the value of IC here? If you have the value of the IC, then you can find the VC. So IC is nothing but beta times of IB. So IC you can find beta times of IB. Now you have the value of the beta 165 into what? 0.01, that is the value of the IB. So it will become 1.65 milliampere. You can also find the IC is equal to what? Alpha I. I you have the value, and then again you will get the same answer. You can check. Okay. Now once you have the value of IC, this is the current IC. So what is the value of the VC? VC will become 5 into IC minus 10. This is the minus 10. 5 into IC minus 10. IC is 1.65 minus 10. Now 5 into 1.65 minus 10 minus 1.75 volt, minus 1.75 volt. Okay, this is the value of VC. Now in a PNP transistor you have to check what? VCE. You have to check VCE. VEC. VEC means VE minus VC, and that should be greater than or equal to VEC saturation. What is the VE? VE is given in the question 1.7. VE is given as question 1.7 minus of minus 1.75. Minus minus it will become what? Plus, and this will become 3.45, right? 3.45. And what is this 3.45 volt? It is greater than what? 0.2 volt. So in case of PNP transistor, you have to check with VEC, not VCE set. You have to change the subscript. Otherwise, if you are going to check with the VCE set, it is negative value. Just change the subscript, it is a positive value. So it is greater than 0.2 volt. That is the BJT is in what? Active region. So that is the question on PNP transistor. Very, very simple. And from the textbook, quickly you can practice all these type of questions. Right? You will get the command over the topic. In books, we are getting the systematic questions. From in one chapter, number of solved example, number of unsolved numerical. Then you will get the command over the topic. Now next one. This is a very easy one. I think all the questions solved in this particular question. That is what is given. Yes, find alpha, find the beta. What is the voltage VC do you expect at the collector? Okay, over. and you have verified that is the BJT is in what? Active region. Now next one. Okay, watch this. The diagram is not given. You have to draw the diagram. That is again another type of challenge. If the diagram is not given, consider a PNP with VEB 0.7 volt at I is equal to 1 milliampere. Okay, I is equal to what? 1 milliampere. Then simply that is characteristics is given. Zero 0.7 when I is what? 1 milliampere. Because it is the PNP it is talking, it is the input characteristics of PNP transistor. I is 1 milliampere when VEB is 0.7 volt. Let the base be grounded. So base, you have to draw the PNP transistor. This is the PNP transistor. Base is grounded. Okay, no problem. Base is grounded, fed by a 2 milliampere constant current source. Fed emitter be fed by a 2 milliampere constant current source. This is the 2 milliampere constant current source. And the collector be connected to a minus 5 volt supply through a 1 kilo ohm resistors. When it is given, this is minus 5 volt collector and 1 kilo ohm resistor. Through a 1 kilo ohm resistor minus 5 volt it is given. If the temperature increases by 30 degrees centigrade, find the change in the emitter and collector voltages. What is the, where is the emitter voltage? Here. Where is the collector voltage? Here we see. Neglect the effect of ICBO. You have to neglect the effect of what? Reverse saturation current, guys. So when we have to neglect the emitter current, then remember, this is the question, very, very simple 1 mark question. You have to calculate the effect on VE and effect on VC. First of all, beta is not given, alpha is not given. So we can assume that IB negligible. Why? If the beta is not given means we can assume beta is very, very, very greater than 1 and the base current is negligible and IC and IE are equal. So same current will pass here. 2 milliampere. What is the collector current? IC 2 milliampere. Now when the temperature increases, guys, when temperature increases, that current is a constant current source. It will remain same. It will remain same. This value will remain 1 kilo. So what about the effect of VC? VC will remain same. There is no change in VC. What is question? I'll find the changes in the emitter and collector voltage. So what is the change in the collector voltage? 0. Change in the collector voltage is 0. Then second question, what is the change in what? Emitter voltage. Yes. Now emitter voltage is, this is the emitter VEB. This is the VEB. Guys, remember one thing. 1 minute. No, this is the characteristics. Okay, suppose this is the voltage. We have no idea about the voltage. This is the 2 milliampere. That is the let voltage. Now, when we are increasing the temperature, the curve will shift. Now, for same drop, for same current, the drop across the diode will decrease. Drop across the diode will decrease. That is the for same current. So constant current 2 milliampere, then voltage will decrease. And what is the change in the voltage? With the temperature, dEB by dt is nothing but minus 2. Normally it is minus 2 millivolt per degree centigrade. In numerical they will give you the value. Otherwise it is what? From minus 1.7 milliampere to 2.5 millivolt per degree centigrade according to the different textbook. In Sedra and Smith, that is the minus 2.0 millivolt per degree centigrade. Means when the temperature increases by 1 volt, when the temperature increases by 1 volt, the drop across the forward bias junction will reduce by 1 volt. So what is the change in the day? The change in VB is given by -2 into change in the temperature. And what is the change in the temperature here given? The temperature is increased by 30 degree. So this is nothing but change in the temperature, 30 multiplied. It is the -60 millivolt. Means VEB. And what is the B? VEB is nothing but VE minus VB. VB is connected to ground, so that is the VE only, because that base is connected to ground here. So VEB is nothing but V. So that change is nothing but change in V, because B is free. This is the -60 millivolt. Means it will reduce by the 60 millivolt. So you have to give the answer. Very, very important question. Very, very important question. Yes, that is the value. That is the value for this question. So in the previous question, already I have given what is the alpha, what is the beta. In this question, take care of that value, that what about the voltage across the transistor. It will reduce by that value, and that value is required in case of what? Biasing and stabilization. We have the problem of the temperature. Temperature increases and drop across the transistor will reduce. Okay, so that is the variation here. I think now it is clear. Okay, tell me. Okay, then next one. Find the output resistance of a BJT for which VA is equal to 100 volt at IC is equal to 0.11 or 10 milliampere. Now, I'm trying to cover what different types of topics here. So now the questions on what? Early effect. So questions on early effect means this is the characteristics. Early effect. Okay. Now, this is the characteristics of BJT. Elevated curve we are having. And so on. Now, when we are extending behind this, they will meet at particular point. And that point is called early voltage. This voltage is early voltage minus VA. Okay, and this is IC. This is VCE. Characteristics of common emitter configuration. And these are, here we are having the different values of IB. One, two, three, four. 1, 2, 3, 4. Okay. Now, what is the find the output resistance? With the help of early voltage, we can find the output resistance. So what is the output resistance formula? Here, output resistance means the reciprocal of the slope of this point. Reciprocal of the slope of this point. For example, if you want to find the slope of this portion, then what is the change in VC, and because of that, what is the change in IC? This is the change in VC, and because of this change in IC, when we are keeping IB constant or VBE constant, there is no change in the current, but there is a change in only VC. So that is the reciprocal of the slope to output resistance is nothing but change in VC upon change in IC. When IB we are keeping this constant. Or to make IB constant, we are keeping actually VBE constant. So so that IB will remain constant. Okay, so that is the case. For example, this is the transistor. We are having the two voltages. First of all, VC, and then second is what? VB. We are keeping the VB constant, and because of that IB will remain constant, but we are changing the VC. So that is the diagram. Then what is the R0? R0 is given by early voltage divided by what? IC. So 100 divided by 0.1, you will get 1000 kilo ohm. Because it is in milliampere, it is nothing but 1 mega ohm. It is the first case. Second case, R0 will become 100 divided by 1, 100 kilo. Third case, R0 will become 10 divided by 1, 100 divided by 10, 100 divided by 10, 10 kilo. So when we are increasing the value of the current, output resistance decreases. It is not constant. It depends upon the early voltage that is fixed. But when we are increasing the biasing current, right, then output resistance will decrease. In analog, you have to consider this effect. This is a very, very important one. That is the case. Remember, now that is the value of different values of R0. Where we are using the R0 in a small signal model, guys. In a small signal model, for example, in hybrid pi model, you have to use the R0 in AC analysis. I will try to conduct one session on that. If you want, then please give me the comments. This is the GMV pi, and here we are having the R0. That is because of early effect. That is E, this is C, and this voltage is called VCE. And here we are having R pi, this is RB, this is V pi. That is the small signal model. Okay, and R0 is called output resistance, and V pi is the voltage, and GM is called transconductance. So that is the model. If you want to use this model, you have to find the R0. In particular, numerical, if the early voltage is given, then you can find the R0 here. Okay then. So that is the diagram. Now, this question is over. Next question. Next question again depend upon this diagram, early effect. If you want the PDF of this session, then please join my Telegram channel. Okay. What is the next question? Consider the circuit in figure 3.19. What is the 3.19 figure? Same figure. This is the VCE. Okay. And this is the VBE. VB is adjusted to yield a collector current of 1 milliampere. Initially, VB are adjusted so that we are getting some IB here. Because of that IB, we are getting some IC here. And what is IC is adjusted? 1 milliampere initially. And what is the value of VC? 1 volt. Initially, it is 1 volt. Now, what is written? That is important. Then, while VB kept constant, this is now constant. If it is constant, means IB is constant. Right? When IB is constant, so guys, VC is raised to 11 volt. Now VCE is increased up to what? 11 volt. Find the new value of IC. For this transistor, early voltage is 100 volt. For this transistor, early voltage is 100 volt. Suppose you are keeping the VB constant. Right, you are keeping the VB constant, IB constant. So how the IC will increase? Remember, IC is equal to what? Beta IB plus 1 plus beta times of IC. Suppose we are neglecting the reverse saturation current, again the IC is equal to what? Beta IB. Now if this is constant, then remember that there is a variation in beta because of early factor base width modulation. Because of that, we have elevated curve. Now exactly at this point, it is first point is given here. When the VC is 1, value of the VCE is 1 volt, what is the value of the current? 1 milliampere. Now we are increasing the VCE up to what? 11 volt. By keeping IB constant means same line. When it is increased up to 11 volt. If you want, then you can remove all these lines because it is not required, only constant IB, there is no change in IB, so you can remove only one line. So if the VC is increased up to 11 volt, what is the value of the current you have to find? That is the question. I think the question is clear. First of all, question, you have to clear the question. What is the value of the IC2? Yes. IC is greater than that 1 milliampere. And there is a change in the current because of what? Change in the VC. What is the change in VC? 11 volt. VC is 11 volt. Now you have to find the slope of this line. What is the slope of this line? Now how we can find the slope? Because VA is given as 100 volt. The slope means slope of this line, change in IC because of change in VC is given by, this is the I2. What is the I2? 1 minus I1, this is the 0. 1 x2 minus x1, y2 minus y1 upon x2. What is x2? 1. This is minus 100. Minus of 100. It will become 1 by 101 milliampere per volt. That is the slope of this line. Milliampere per volt. Now if you want to find what is the change here, change is what? That is multiplied to what is the change in IC. The change in IC is given by slope into change in VCE. So what is the change in VCE? 11 minus 1, 10 volt. So 1 upon 101 into 10. That has become 10 divided by 101. This is nearly equal to 0.1 milliampere. This is the change. So change means what? If the value at this point is 1 milliampere, after change it will become what? 1.1 milliampere. What is the new value of IC? Find the new value of IC. New value of IC is given by old value of IC plus what? Change. 1 plus 0.1 nearly equal to that 1.1 milliampere. This is the answer. 1.1 milliampere. That is a very, very important question, guys. How we can find the early effect. How we can find the early effect, guys. So that is depends upon the early effect. I think now this is also clear to you. 1.1 milliampere. This is again. So already I have covered one question on what NPN transistor, one question on PNP transistor. Now two questions on what early effect. Now next one. Next question. So this is the questions from Sedra and Smith. Now next one. Okay. Transistor is given, example 3.3. Try to solve this question. The transistor in figure 3.33 is specified to have beta in the range of 50 to 150. Again, that is a very tricky question. Beta is variable from 50 to 150. Find the value of RB that results in saturation. With an overdrive factor of at least 10. So everything is asked. What is the value of RB? What is the overdrive factor? With this question, you will get the idea about all this. Tell me what is the answer. Overdrive factor of at least 10. Now, first of all, beta. Now the beta has two values, 50 and 150. That is the range of the beta. And transistor should be in active region. So always remember, for this we will choose lower value of the beta. So if beta will vary, then you have to choose the beta is equal to what? 50. For this value, if the transistor is in saturation, 100% sure it will be saturation for 150. Because when we are increasing the beta, IB will increase, IC will increase, and automatically the transistor will goes into saturation. Means if it is in saturation for beta is equal to 50, then it will be in saturation for beta is equal to what? 150. Then you have to choose the beta 50. I will again explain this with next question. The beta 50 minimum value choose. Now, what is asked? What is the overdrive factor? Now, let the BJT in saturation. Always, if you want to solve the question on based on saturation, always assume let BJT is in saturation. BJT is in saturation. Once it is in saturation, guys, what is the value of VCE? This will become VCE set. VCE is what? VCE set, and VB is what? VB set. Normally we are taking now these days VB 0.7 volt. VCE set is 0.2 volt. This is fixed at 0.2 volt. You can find the value of IC. So IC is nothing but IC set. It is given by VCC minus VCE set upon RC. Then VCC. What is the VCC? 10 volt. 0.2 divided by RC 1 kilo ohm. It will become 9.8 milliampere. 9.8 milliampere. That is what saturated current. Now, what is the minimum IB required for saturation? So, always remember this graph. Okay. Now, in active region, it will follow this line. Approximated diagram. In saturation region, it will become saturated like this. Oh, sorry. Oh, like this. Now, this is called what? IC set. This is IC. This is IB. Up in active region, in this region, slope is beta, and after that it is IC saturation. So this is called IB minimum. And this is the boundary of what? Saturation and active region. So exactly at boundary, IC is given by IC set. It is given by beta times of IB minimum. IC set beta times of IB minimum. Yes, I will explain what is the overdrive factor. So IB minimum, what is the minimum base current required for the saturation? So exactly it is given by IC set divided by beta. IC set divided by beta. So this is the minimum base current required for what? Saturation. Now, what is the IC set here? 9.8. 9.8 divided by what? 50. This will give you the minimum base current required for the saturation. So what is the minimum base current required for the saturation? 9.8 divided by 50. 0.196. 0.196 milliampere. That is required for what? Saturation. Now suppose you are choosing the beta is equal to what? 150, because beta vary from the 50 to 150. Then what is the minimum base current required for the saturation? It will reduce. This is the value for beta is equal to what? 50. Now if you are choosing the beta 150, then it will become IB minimum is equal to what? 9.8 divided by 150. 9.8 divided by 150. 9.8 divided by 150. Then it will become 0.065 only. Guys, remember, if suppose you are giving this current greater than that, try to understand. If the base current is greater than that, definitely it is greater than this value. Means transistor is in what? Saturation. But opposite. If the base current is greater than that, no doubt transistor is in saturation for beta is equal to 150. But suppose there is a variation in beta, beta will become 50, but the current is greater than that, but it is less than this. It is not guaranteed. That's why we have to check the condition with beta is equal to 50, not with what? 150. So that is the, now you have the minimum base current. Now what is the meaning of the overdrive factor, guys? Overdrive factor means, overdrive factor means the current in this diagram, what is the actual current IB IB is given by, this is called VBB. VBB minus VBE upon RB. This is the actual current. This first thing, for saturation, this IB should be greater than IB minimum. For saturation, this IB should be greater than or equal to IB minimum. Okay. Then how many times? If it is just equal, then again it is at the boundary of saturation. But if you want to keep, definitely it should be in saturation, then IB should be 2 to 10 times of IB minimum. If you want to keep transistor in saturation, then IB should be 2 to 10 times of IB minimum. That is called overdrive factor. If suppose the overdrive factor is given as at least 10, means what is the meaning of this? You want that IB should be 10 times of IB minimum. This is called overdrive factor. Overdrive means oversaturated. Overdrive factor. This is 10. So what is the IB? Actual IB is 10 times of IB minimum. So this has become 10 into 0.196. Because IB is what? 0.196. It will become 1.96. So 1.96 milliampere IB is required. Okay, Pradeep? 1.96 IB is required. So what is question? What is asked in the question? What is the value of RB? Find the value of RB that will result in saturation with an overdrive factor of at least 10. So RB is required. So now you have IB is equal to what? 5 minus 0.7 upon RB. Because this voltage is 0.7 VB. 5 minus 0.7 upon RB is equal to IB. So what is the RB is equal to? 4.3 divided by IB. And what is the IB required? 1.96. 1.96 milliampere. Now tell me, if you have no idea about the overdrive factor, again this question is very easy. Can you solve it? So 2.1938 kilo, or you can say 2.2 kilo, more or less than that. So that is the value. At least 10, yes, and then greater than that. So IB, RB is the value. Okay. This is the answer for this question. So you can solve. Tell me any doubt then. So this is the question. I can give you the page number also. If you want to solve, guys, just I want to motivate you to solve some questions from standard textbook. That is like what Sedran Smith, Millman Helkias, or what Sadiku, Alexander and Sadiku for network. How many students you have started solving the question? Some selected numericals. Why selected numericals? Because we have limited time. ज़्यादा नहीं, बस थोड़े बहुत सॉल्व करते जाइए. जैसे ये क्वेश्चन था, क्वेश्चन नंबर, what was the question number? Page number, note the page number. This is the 6th edition, page number 206, RB. Okay. So already I have given what is the overdrive factor and so on. So this is the value, nearly equal to 2.2 kilo ohm. That is the answer for this question. At least 10. Now Bhanu, it is clear what is the overdrive factor. And remember this diagram. If the IB is less than IB minimum, it is in active region. IB is greater than IB minimum, it is in saturation region. Exactly at boundary, it will satisfy IC set is equal to beta times of IB minimum. So you can find this. And always remember, if the beta range of the beta is given, you have to choose what lower value of beta. If it is in saturation for lower value of beta, then definitely it will be in saturation for what higher value of beta. You can verify it. Higher value of beta, but negative reverse is not true. Yeah, transistor. G means Anis. I am taking the classes for what gate examination. No doubt that is in syllabus of. I think I have no idea about that. What is the weightage? Okay, sorry for that. I will collect data. If suppose I have authentic data, then I can inform you. So this is the overdrive factor. IB upon IB minimum. Now next one. Next question is again very important one. Now this one. Tell me. Consider the circuit in figure for case VCC is equal to 5 volt. VI is equal to 5 volt. VCC is 5 volt. RB and RC 1 kilo ohm. Only 1 kilo ohm. This is the RC 1 kilo ohm. This is 1 kilo ohm. Beta 100. Calculate the base current, collector current and collector voltage. So base current, collector voltage. If the transistor is saturated, that is important. Remember, if the transistor is in saturation, this voltage is fixed. VCE set. And what is the VCE set? 0.2 volt. This is fixed 0.7 volt. VBE 0.7 volt. So directly you can find the collector current. Very easy. VCC minus VCE set 5 minus 0.2 divided by 1, that has become 4.8 milliampere. 4.8 milliampere, that is the value of IC set. IC set, VCC minus VCE set upon RC. This is called IC set, saturated current. Then what is the actual IB here? IB is 5 minus 0.7 upon this. 5 minus 0.7 upon RB, again it is 4.3 milliampere. So that is the actual current in the circuit, 4.3 milliampere. Okay. Now beta 100 is given. Calculate the base current, collector current and collector voltage. Collector voltage means this VC. So already VCE set is nothing but VC. So collector voltage will become VC is equal to VCE set. Why? Because emitter is connected to ground. So it is 0.2 volt. Okay. Now what value should RB is? No, first of all, if the transistor is saturated, calculate the base current, collector voltage. It is over. Find the beta forced. First of all, you have to solve this question. Find the beta forced. It is called forced beta. What is the meaning of the, yes, high na Bhanu? Okay, because it is in saturation. That's why we will calculate what is the beta force. What is the meaning of the beta forced? Beta forced means, okay, what is the beta forced? Beta forced means, now suppose if it is in a IB minimum is required in this circuit. So already I have given you the diagram, this one. This condition should be satisfied. This is called IB, this is called IC set, and this is the IB, that is in saturation. Now if this IB is fixed, this IC is fixed, what is the meaning of the beta forced? That will force the transistor to move into a saturation. So you have to satisfy the condition IB should be greater than or equal to what? IC set divided by beta. That is the actual equation. Exactly at boundary condition IC set, and that this is the IB is fixed. So IB should be greater than or equal to IC set upon beta, that is the IB minimum. This is nothing but IB minimum. But suppose the IB is fixed, IC set is fixed and beta is variable. So what is the beta here? You can find the beta is equal to IC set divided by IB. It should be greater than or equal to this value. Beta should be greater than or equal to this value. Then the transistor will be in saturation for fixed value of IC and fixed value of IB. That beta is called beta forced. It will force the transistor to move into what? Saturation. Now you can put the value here. So what is the value of the IC set? What is the value of the IC set? 4.8. What is the value of the IB? 4.3, very high. So 4.8 and 4.3. So this means what is the value of the beta forced? That will force the transistor to move into the saturation. So you can find 4.8 divided by 4.3. 1.16116. Only. Means beta is required only 1.116. If the beta is greater than or equal to that, the transistor will be in saturation. So my dear friends, what is the beta given in the question? 100. Beta given in the question is 100. So beta is very large as compared to beta forced. Beta forced means required value of the beta, minimum value of the beta for which transistor will be in saturation for saturated value of IC and fixed value of IB. Beta is very large. 100 is very greater than what? 1.116. And that's why definitely that transistor is in what? Saturation. Now it is clear, Bhanu? This is the current, everyone. Now, second thing, what is asked here? Bring the transistor up now. That is the second question. What value should RB be raised? Now when we are increasing the RB, what will happen? Suppose we are increasing the RB, IB will reduce. So what value of should RB is raised in order to bring the transistor to the edge of the saturation? Edge of the saturation means at this point. At this point means here we are having the current, it is well in saturation. Now when we are increasing the RB, current will reduce. When it will become exactly equal to IB minimum, then we can say it is at the edge of the saturation. So at the edge of the saturation, simply write down the formula. At the edge of saturation, IB should be equal to what? IB minimum. IB should be equal to IB minimum. And what is the IB minimum? As you know, IB minimum is given by IC set divided by beta. So what is the IC set? 4.8 milliampere. It is already we have calculated. And what is the beta value is given? 100. This is the minimum. It should be equal to that. And what is the IB? IB is given by VBB minus VBE upon RB. This is the value of IB. VBB, this is the VI. VI is nothing but VBB. VI minus VBE upon RB. So what is the VI? It is given in the question 5. VI is given as 5. So you can use this formula 5. This should be equal to what? IB minimum means 4.8 divided by 100. So this is 5 minus 0.7 upon RB should be equal to 4.8 upon 100. Then you can say at the edge of the saturation, RB should be equal to 4.3 into 100 divided by 4.8 kilo ohm. RB should be greater than or equal to that, then at the edge of saturation, or it will enter into the active region, because when we are increasing the RB, current will reduce. So what is the value of RB? 4300 divided by 4.8. Right? And no, 43, not 430 divided by 4.8. 89.58 nearly equal to kilo. When we are increasing the RB up to this point or more than that, then it will be in what? It will enter into what? Active region. Or exactly at this value, it is just at the edge of the saturation. This is called edge of the saturation. Exactly at the boundary of what? Active and saturation region, guys. So that is the case. So this is a very good good question on what? Saturation, how we can judge. So in numerical, normally in electrical branch or electronics branch, we are getting questions from what? Saturation region, active region, cutoff region. These are very important one. Please try to solve this question. Then next one. So again, yes, before entering to the next question, this is very important information for you. We have around 2 months, means around 75 days for what? GATE examination. So already I have taken one session for that. I will upload that link of that. That is link is given on my Telegram channel. 25 plus 25 plus 25 strategy for next 75 days. You can watch that session. That link is given on my Telegram channel. Right? Yes, I will, Akanksha I will explain. Then mega mock test. Because it is time to start giving the mock test. If you want to give the full length mock test, then first of all install BYJU'S exam prep app from Google Play Store. Okay, the number of mock tests are available, and this is the mega mock test, means that is the all the sequence is given here, and already it is my on Telegram channel also, that is Electronics by Sanjay Rathi. 65 questions, 3 hours, right? MCQ, MSQ, न्यूमेरिकल आंसर टाइप क्वेश्चन, और बिल्कुल जैसा आपका पेपर में होता है ना वैसा कंप्यूटर बेस्ड टेस्ट, तो आप दे दीजिए मॉक टेस्ट, लेकिन उससे पहले आप रजिस्टर कर लीजिए यहाँ पर, और डिस्क्रिप्शन दिया हुआ है राइट, वहाँ आप जा सकते हैं। हाँ, आप देखते हैं जरा, ये है नेक्स्ट क्वेश्चन, व्हाट यू आर आस्किंग आकांक्षा, व्हाट आर द कंडीशन फॉर कट ऑफ? कट ऑफ मीन्स व्हाट, यू हैव टू चेक, you have to check the value here. Always remember, if it is given in the cutoff, what is the whether the BJT is in cutoff, yes or no, then you have to check that VBE. VBE for BJT, for silicon, it should be less than or equal to 0.0 volt for silicon, and collector junction should be reverse bias. Already that, suppose it is given that, for example, collector junction here it is connected, one resistor is connected and this is the 5 volt is connected, means collector junction is reverse bias, and you have to check that VB is less than or equal to 0.0 volt. If it is less than or equal to 0.0 volt, then we can say it is in cutoff. For germanium it will become minus 0.1 for germanium. That value is called cutoff. So cutoff means both the junctions should be reverse bias, but what is the value by which it should be reverse bias? That is the value. Okay, already I think I have solved one question. So what is the value of resistor and so on. So just you can try, otherwise in next class I will solve this question. This is a very, very important question. I have forgot the value, but okay. That is on BJT or from Millman Halkias, that VCC was given I think 10 volt, or RC is something given 3 kilo ohm, and here one value is connected like this. This is the minus 12 volt, 100 kilo ohm, 15 kilo ohm, Vi is given as 1 volt. Now check whether it is in cutoff, yes or no. Okay, Akanksha, you can solve. Now in this question, this voltage is given as 1 volt, this voltage is given as minus 12 volt. So whether this transistor is in cutoff, yes or no. If you have to check whether it is in cutoff, yes or no, then you have to assume that it is in cutoff. Let BJT is in cutoff. So for all the students, focus on the board. So if it is in cutoff, means what is the value of the IC? 0. What is the value of the IB? 0. How we can say 0? Because we are assuming that it is in cutoff. You have to find the voltage at this point so that you can find the value of VB. So VB is connected to ground. So VBE is nothing but VB. VBE is nothing but VB. VB minus V. V is connected to ground. So that's why it is VB. Now you have to apply simply what? KCL. VB minus 1 upon 15. VB minus of minus 12 upon 100. And find the value of the VB. VB minus 1 upon 15 plus VB minus of minus 12 upon 100 is equal to what? 0. Now you have to find the VB. You can take 300 as a LCM. 15, this is the value 20 VB minus 20 plus 3 VB plus 36 is equal to 0. Check my calculation also, that will become 0. And guys, 23 VB. And it will become 36 minus 20 plus 16 minus. Now what is the value of the VB? Negative. Negative. Or if it is negative means what? Less than 0.0. If it is less than 0.0 means, tell me, what about the BJT? It is in active region or cutoff region or saturation region? So once the VBE is less than 0, already the collector junction is reverse bias, emitter junction is also reverse bias, because this value is less than 0.0. That's why the BJT is in cutoff. So you have to first of all assume, and then you have to find the value. This is a very good question in Millman Halkias. That's why I am saying that try to solve some questions from what standard textbook. Okay. Okay, now you can solve this. Easy guys, everyone. And why? VB is nothing but VB. Remember, VB is nothing but VB. This is for NPN transistor, silicon transistor. Now, next one, last question. Then I will give some important assignments to you. So try to solve and give me the answer on my Telegram channel, that is Electronics by Sanjay Rathi, guys, everyone. Then we want to analyze the circuit of figure 3.39. This is the 3.39. To determine the voltage at all the nodes and the currents through all the branches. You have to find the voltage at all the nodes and all the branches. All branches means what is the collector current. Always remember emitter current outside. So this is the base current outside, emitter current inside. This is the emitter current inside, base current outside, collector current outside. Now I is equal to IC plus IB. Determine the voltage at all the nodes. Voltage at all the nodes means what is the V, what is the value of the VC, what is the value of the VEC. It should be, but you have to check. The minimum value of beta is specified to be 30. The minimum value of beta is what? 30. 30 is given. Then what is the value of the VEB? VEB in PNP transistor, VEB is 0.7 volt. In NPN transistor, VB is 0.7 volt. Now, if you have the value, beta is given, then how we can say whether it is in cutoff or it is in saturation or in what active region? In this type of question, you can start with what? Watch this. First of all, you have to. What is the beta? Very, very low value, 30 only is given. So we can assume that this is in what? Active region. But it is not in cutoff. Why it is not in cutoff? Because this is 0, this is the positive. An emitter terminal is connected to positive voltage, base terminal is connected to 0 voltage. That's why this junction is forward bias. Which junction? Emitter junction, because it is a PNP transistor, not NPN transistor. In a case of PNP transistor, if the base is connected to ground, emitter is connected to positive value, means emitter junction is forward bias, means it is not in cutoff. It may be in active region, it may be in saturation region. Now the collector junction is connected to, you can say, sir, collector junction is connected to negative value. Then no, because that resistor will play an important role here. Resistor, it is connected here, it will play important role. We can't say that collector junction is what? Reverse bias. No. First of all, check this. How we can check? Now, what we, because it is not in cutoff, let it is in active region. Let it is in active region. Active region. Now, you can find the value of, for example, this is what? 0.7 volt. This value I will become 1 plus beta times of IB. It in the active region 1 plus beta times of IB, and this is the IB. And this IC will become beta times of IB. So beta is given as 30, so 31 times of IB. Directly you can write a KVL here. KVL from this point to this point. When I am writing the KVL here, it will become 5 is equal to 31 times of IB into 5. This is 1. 31 times of IB into 1 plus 0.7 plus 10 times of IB. Plus 10 times. I am solving the question on PNP transistor, 10 times of IB. So write down the KVL. From this you can find the value of IB. 5 minus 0.7 upon 31 plus 10, 41. This is the milliampere. You can find the value of IB. Now, once you have the value of IB, then as you can find the value of I, 1 plus beta times of that, and you can also find the value of IC. Then write down the KCL at this point to find the value of VEC. To find the value of VEC, I am going to find the value of IC. Beta times of IB. 30 times of, what is the value of the IB? Everyone, 4.3 divided by 41. 0.1048. 30 into that, you can take 49 also, into 30, 3.146. When it is multiplied by the 31, you can find the value of IE. 31 times of IB, that will become 3.25 milliampere. This is the value of IE and IC. Now I write down the KVL from this point to this point. When I am writing the KVL from this point to this point, you can write 5 is equal to 1 into I plus VEC, this is the plus VEC, plus 10 times of IC minus 5 volt. This become plus 10. What is the VEC is equal to 10 minus I minus 10 times of IC. Now find the value. 10 minus I. What is the IE? 3.25. Minus 10 times of IC. What is the IC? 3.146. Is there any need to calculate? Guys, this is what this value is negative. Means less than what VC is set. What is the VEC set? 0.2 volt. That value is less than that, means it is in what? Saturation. It is in what? Saturation. Our assumptions is wrong. BJT is in what? Saturations. When you have the idea that BJT is in saturation, means how we can solve then? Once you have the idea that BJT is in saturation, means simply BJT is in saturation means this voltage is fixed. VEC is set. That is nothing but 0.2 volt. This is IE, this is IC, and this is what IB. But you have to write the KVL. You can't write IC is equal to beta IB. You can't write IC is equal to beta IB, but you can write IE is equal to what? IC plus IB. IE is equal to IC plus IB. That is the one equation. You have to write the two KVL. One from this point to this point. When I am writing 1, 5 is equal to IE into 1 plus 0.2. This is the 0.2 plus 10 times of IC plus minus 5. Minus 5. Okay. And that will become what? 10 is equal to, you can replace IE by what? IC plus IB plus 10 times of IC, and that 0.2 here, it will become 9.8. Right? This is the first equation. Second equation, you have to write the KVL in this point. But remember, you can't write KVL in this point. Why? Again, because we have no idea about this voltage. You have to write the KVL in this point. This is the 0.7 volt. So you have to write the KVL in this line. 5 is equal to 1 times of IE. So what is the IE here? IC plus IB plus 0.7 plus 10 times of what? IB. Now you can arrange this equation. It will become 4.3. This is the 4.3 is equal to IC plus 11 times of IB. So we have the two equations and two unknowns. We have the two equations and two unknowns. You can find the IC, IB and what? IE. Okay. So everyone try to solve this question and give answer in my comments box or detailed answer on my Telegram channel. This is a very, very interesting and challenging question, guys. Very basic questions. Normally we are doing mistake in what? Very basic question. And already I have given the first 25 days focus on basics of all subject. And if you are able to cover the basics of all the subject, minimum 50 to 60% syllabus over. And then for next 40% we have next 25 days. Okay, try to solve questions from standard textbook, try to solve questions from what? Workbook, and that is the homework, guys. This is the homework. Try to solve this question. We desire to evaluate the voltage at all the nodes and the current through all the branches in the circuit. Assume beta. There are two transistors. One is PNP, one is NPN is connected here. And then you have to find the values here. Right? So this is again a very, very important one. Okay, stay tuned with us and please install the BYJU'S exam prep app, because on 9 PM right? On alternate days, I have classes where we are solving questions from what Alexander and Sadiku on BYJU'S exam prep app, 9 p.m. sharp. You can follow me and you can solve important questions. Okay. And if you are giving the mock test on BYJU'S exam prep, that is the leaderboard. You will get the idea, number of students, participants, what is your rank, what is your score, what is your strength, what is your weakness. But you have to start giving the mock test, guys. And if you want to start your journey with us, then this is the 2024 crash course, and that is what Vision Gate 2025 and 2026 complete syllabus. And we are going to cover that syllabus in English and Hindi, live classes, recorded lectures, study material, practice quizzes, mock test. For more detail, you can call at this number. Okay. To go through description, you will get the number and get the detail about all these courses. This is my channel Electronics by Sanjay Rathi. I will upload the PDF on this channel. So go through that, go through the solution, try to solve the assignments on rough copy and pen and use virtual calculator only. Okay, and then get whether you are getting the right answer or wrong. According to my experience, these all questions are important one. Okay, then thank you for attending the session. You are on BYJU'S exam prep. Like the session, share the link of this session and subscribe our channel. Have a nice day.